In this demo, we are going to look at Swift use case for DR for IBM OpenShift. Here, source cluster environment is IBM Satellite OpenShift, which is deployed on AWS, having OpenShift version as 4.9 and Kubernetes version as 1.22. The cluster is deployed in US East to AWS region. The source Blogger app that we are going to migrate contains PVC of storage, satellite, AWS block gold metro. And for target environment, the cluster is IBM OpenShift deployed on classic infrastructure, having OpenShift version as 4.9 and Kubernetes version as 1.22. The cluster is deployed in Dallas region, which will contain IBMC block gold storage class for our migrated application on destination cluster. So let's have closer look at source and target environment for our migration. So this is our source satellite cluster having satellite location as AWS US East 2 and having infrastructure as satellite. This is our satellite location for the OpenShift satellite cluster, having total 6 hosts, out of which 3 hosts are assigned for control plane and 3 hosts are assigned for our OpenShift cluster. So these are the EC2 instances which are used by satellite cluster for deployment. Now let's have a closer look at our source application. So this is our source application which is deployed on project WordPress source, which contains 2 deployment config objects. And if we expose them by using route resource, this is our WordPress website for demo purpose. And apart from deployment config objects, our WordPress source contains one build config which has status has complete, like build is completed for this build config, and respective image stream is ready to use for our application. So here we will migrate all the image streams and build configs also, which are required for building the image and respective application. Now let's look at our target cluster environment. Our target cluster is deployed on classic infrastructure having OpenShift version as 4.9. So if we look at the OpenShift web console, here I have created WordPress destination namespace for the target cluster, which doesn't contain any resources yet. Now we will use Swift to migrate and use DR for migrating application from source cluster to target cluster. Here is a Swift GUI where we have to use proper credential for login. If you are configuring Swift for the first time, you need to configure your user and password by using Swift CLI user modify command on Swift. Swift GUI is accessible by Swift IP/Swift/dashboard. And if you want to know more about Swift product, you can download and read operation guide and prerequisites or installation guide. So let's log into the Swift machine. So upon logging in, you will see container cluster administration page. The container cluster administration page is used for adding source and target clusters. Here in our case, source cluster is IBM Satellite OpenShift and target cluster is IBM OpenShift cluster. So we will add both the cluster information here. So we will click on add. And these are the options which are necessary for adding the cluster in Swift. Here I have added necessary details for adding the cluster into Swift. So here for adding source IBM cluster, I have selected cloud type as IBM OpenShift Container Platform OCP, and here I have given actual cluster name, and for authentication purposes we need to upload IBM API key here, which I have uploaded, and I have also added tripod image and tripod image secret here. So these are the options which are required for discovering IBM Satellite source cluster. So I will add this cluster. So similarly, I will add destination IBM cluster into the Swift. In this way, I have added source and target clusters in Swift. And if we expand the information for that cluster, you can see the summary of clusters and also the objects which are discovered by Swift. So in each namespace, we can see the objects discovered by Swift. Now we will see how we can migrate the IBM OpenShift source clusters application into IBM OpenShift destination cluster. For that, we will go in business continuity and DR. First of all, we will create a storage pool. Storage pool is used for taking a backup of application PVCs into our Swift machine. So we will provide storage pool friendly name. We will select storage manager type as ZFS, and for block devices we will dev/sdb1, and we will set this storage pool as default to be used by stage 1 things, and we will create this storage pool. Now you can see that storage pool SP1 has successfully created and it has status as online. This storage pool is used for backing up source OpenShift application data into our Swift machine. To create backup of source OpenShift application data, we will create stage 1 sinks in our Swift machine. To create stage 1 sink, go to sink administration and all replications. Create new application replication. So these are the options that we require to fill to create stage 1 application replication. So for the sink type, there are 3 sink types supported by Swift. So first one is pass-through, where source application is migrated directly to the target cluster. Second one is stage 1, where backup of source applications is created on Swift machine. And third is stage 2, where the backup created on Swift machine is migrated on target cluster. So here we will select stage 1 for the demo. And for source cluster platform type, we will select OpenShift and we will select cluster name as IBM Satellite Source. And in the project section, we will select WordPress source application to take backup of the data. And in applications, we will select all so that all applications will be backed up in the namespace WordPress source. And now we need to fill up tripod options. Tripod is a transient RackWare agent image pod which collects and migrates all the data from the PVCs into the target cluster. So it requires certain details to fill. So for the IP address, here I will give IP address of one of the node of IBM Satellite cluster. So this IP should be public so that Swift can access this address. And for the IP type, we will select node port. And for try ports, we will give proper control and data ports within certain range. So we will give some arbitrary ports. And this is the image which will be used by tripod to deploy and run properly. And this is the image pull secret which is required to pull this image from the registry. So these are all the source related options. And for the target, as we are taking backup of data, we will select proper storage pool. So that all application data backup will be created in the storage pool, and we will name image group as IBM IG. So all the application data will be backed up in IBM IG image group. So we will add this stage 1 sync. Now stage 1 sync is running, and you can see that it has job summary, so and the options that we gave to create this sync. And we can also see sync progress, like what other actions this sync is performing. So this sync is running now to take backup of source OpenShift application data. Now you can see that stage 1 sync has completed, and you can see data sync statistics, that is how much data Swift has migrated. So we have successfully created stage 1 sync for taking backup of source application data into our Swift machine. Now we will create stage 2 sync to migrate backed up data on Swift machine into the target cluster. After creating stage 1 sync, we will now create stage 2 sync. To create stage 2 sync, click on New Application Replication. Here, select sync type as stage 2 and target OpenShift cluster name as IBM OpenShift destination. Here, for the source image group, we will select IBM IG image group that we created in previous step. And for the project, we will select WordPress destination project for target OpenShift cluster. And we will select all applications to sync, so that all applications in the namespace will be selected for syncing. And we will select proper zone. And for tripod options, we will select IP type as load balancer. And for control and data port, we will select 30444 and 30566 arbitrary ports. And now we will add the sync. So sync is running now. See that stage 2 sync has been completed, and if we go to the data sync statistics, it has transferred certain amount of data. And also in the object sync statistics, you can see that how many objects Swift has migrated. So let's go to the WordPress destination project where we have migrated our applications. Now you can see that there is one deployment config, one persistent volume claim, and other objects that are synced by the Swift. Now let's go to the route that we migrated. So this is the route, and if we go to this location, we can see that source cluster website has successfully migrated. So our Swift was successful in migrating applications from source cluster to target cluster. Now we will create DR policy schedule to continuously run stage 1 and stage 2 sync in the background. So To create a new DR policy, we will create new and we will name the DR policy as policy 2 and we will select sync type as stage 1 plus 2. Here we will select periodicity as sync will execute after every 15 minutes and we can also exclude it on Sunday. And for stage 2 schedule, we will also create stage 2 for every 15 minutes and we will exclude it on certain days. Also, we can get email notifications for any sync failures or progress. So I will add example email here for the email alert settings and you can also click these options to configure email alerts only on sync failure. So we have filled all the options. Now we will create the DR policy. After DR policy has created, we can apply it. So we will apply the DR policy 2 and we will fill start time as start immediately. And for stage 1 plus 2 applications, I will select job 50 for stage 1 that we executed. And for stage 2, we will select job 3. And for fallback configuration, I will select the respective jobs. Now we will apply the DR policy. So now DR policy is successfully applied. We can also unapply or delete or pause the DR policy that we have applied. Also, we can do failover and fallback on the applied DR policy. Let's failover the DR policy 2. So for that, I will select the DR operation that needs to be failed over. So I will select all DR applications to failover and I will run failover in a drill mode, that is in the test mode. So there won't be actual failover. I will only test the failover operation by selecting drill mode. And this force stage 2 sync option is to force stage 2 sync even if stage 1 sync hasn't completed. So I will failover the policy 2. So the policy state is drill failed over now. We can also fall back the failed over policy. For DR policy fallback, I will select the DR operation to fallback and I can select reversing to sync reverse in a reverse fashion so that target cluster becomes source cluster and source cluster becomes target. So in this way, we can also fall back the operation. So this was regarding failover and fallback. Thus, by using Swift, we can schedule the DR policies according to our need and also failover and fallback whenever needed. That's it for this demo. Thanks for listening.